Hello, everyone. Good evening, good morning, good afternoon, whatever time it is for you. Welcome to another stream. I will be doing something very exciting today. At least it's exciting for me. I don't know if it's just as exciting for you. We are going to be looking at Pokemon. Do let me know if you are excited, and if you're watching, where are you watching from? Write in chat. Ask questions, as usual. If it's your first time here, welcome and thank you for joining. I'm Matty Two Shoes, or Matthew, or Maddie, and I am a data analyst, not a data scientist. I am a digital analyst, I'm a little bit of a data engineer. I work with data a lot, with different people. And so I like to share what I do with data with others. Because I've been fortunate enough over the years to be taught and given the opportunity to learn from some of the greats within our industry, and therefore I want to give back. And so I use this stream as an opportunity to do so, and therefore you are more than welcome to ask questions at any time. There are no stupid questions, only stupid answers, but I'm responsible for those, not you. And as I said, we'll be looking at Pokemon today. So if you're a Pokemon fan, let me know if you're already singing the gotta catch 'em all. We'll be looking at Pokemon today, not the games specifically, but rather the Pokemon themselves. And I had some help from a colleague of mine with this prior to today, because I was curious whether the dataset was complete, let's say. And it turns out that actually the data I had downloaded had some inaccuracies in it, so I was very helpful for his support. And so I am happy with the dataset that I have now, and I think we can do some interesting things with it. So let's jump over to what is planned today. So tell me who loves Pokemon, really. I mean, it is such a huge thing. Honestly, it's one of the biggest franchises. I think it's actually possibly the biggest franchise in the world. And of course, it's incredible, really. I mean, I played it certainly a few years back since the last time I played. But as a kid, I played this a lot. And I used to remember taking cables to bridge two Game Boys together so that we could trade Mew or Mewtwo. And this is first generation Pokemon. Now we are in the 8th generation, if you can believe that. Over 800 Pokemon now. No longer just the original 150 OG Pokemon. So, what... you may be asking yourself, what can we even do with Pokemon? I mean, really, there's only 800 something records. But actually, it's pretty interesting to think of it from a game dynamics point of view. And so that's something that's fascinated me for a long time, and so we're a little bit in uncharted territory today. Me, definitely. I don't know about you, but I am. So I would love to go deeper in the field of sort of gaming analytics or analyzing games, and I've been in discussions with quite a few people in the past about analyzing video games. But it is very difficult. I mean, there's a lot of huge publishers and proprietary data sets, and they're not just going to start releasing all the data from Call of Duty, right? So this is a little bit closer to that goal. So if you have questions about what we are going to find out today, those questions are legitimate because I have the same questions. I don't know what we're going to find out today. Maybe we won't find out anything interesting at all and we're going to end the stream after 35 minutes. I hope that's not the case, but I'm hoping to find out a few things. The first thing we need to do is we definitely need to bring out some basic stats about Pokemon, because I've been out of touch with Pokemon for years now, and I don't know everything in depth anymore. So I would like to have some basic idea of, you know, how many types are there and all this kind of stuff, just some basic stuff to describe the game. And maybe we can even describe how the game works a little bit in that way, but I think the mechanics are familiar to most people. Yeah, we want to know how often what ability is spread across the base of all the Pokemon. Something, because, you know, Pokemon can learn moves. They can also learn new moves by combining two Pokemon, where it gets a little bit complicated. Also, Pokemon can have different forms based on regions and things like that, like Rattata. You know, and then maybe some things like a correlation matrix might be in there, which would be the first time for me doing that in SQL. It would be pretty exciting if we could get that to work. Like, how does height and weight correlate with the base stats? Does it have any effect whatsoever? My colleague was skeptical. Who knows? We don't know unless we know and find out, with the data telling us so. But I mean, it may not have any effect whatsoever. But there could be other things that have an effect, right? One of the main things we'll be looking at, I think, is what Pokemon types take least or most damage from which types of attacks. So there's these, I believe, 18 different attack types. I think these, yeah, against here. I'll come back to the data in a second. So that's interesting. And so maybe we can build a dream team. That would be obviously the most amazing situation, would be picking 6 Pokemon maximum that do the most damage while remaining relatively impervious to any other teams of 6 Pokemon. I think that's a pretty high order, tall order for today. And also something like, okay, if we have the right team, how much effort would it take to get us to level 100? Because of course these Pokemon need to be leveled up as well, and they have different experience requirements. So that would be also something interesting to look at. So that is kind of what's planned today, if that makes sense for you guys. As I said, if you have questions, feel free to write in chat. Yeah, one thing to note, the dataset might be slightly out of date due to DLC. So there might be some things missing or some things that are slightly inaccurate. We'll just assume that the data is pretty good that we're working with. It's an assumption, right? As with all assumptions, it carries some risk, but I think it's acceptable. And we will also go into some details about the dataset itself. So the dataset I'm actually working with is a merge or a fusion of 2 separate datasets from Kaggle that I've put together. And the reason for that is this inaccuracy with one of these datasets. I'm not going to go into too much detail about the inaccuracy, but basically a Pokemon can have different forms, and these different forms were not accounted for in one of the datasets, so I basically had to put these 2 together, and I'm keeping this here so that I can reference it later if we are not sure what exactly the capture rate is, although the description doesn't really help us. But if we're not sure about something like yeah, like the cereal or something like that, there's some description here about what those things are. I've done my best to read this and inform myself, but of course I may have forgotten some of the things, so I'll come back to it later. If you'd like to have this information, I'm happy to send it to you or publish it somewhere, so just let me know if you want to have the data as well. I can also make the data available if you would also like to look at it. Yeah, that's something I haven't done until now, but if that's something you would like, there's actually a suggestion box on my Twitch profile in the About, and you can just pop that in there and I will see how I can do that. So I think it's time to get started. Let's get started then. Seems like a good moment to do that. So we have our trusty DataGrip console. We have, if you're not familiar with my setup, I'm running Postgres database. Someone asked last time about different database types. I personally am a huge fan of Postgres because it allows me to use a lot of functions that are really, really complex if written out in like separate steps. Like, I don't know, regex to table and stuff like that, which doesn't exist. It doesn't exist in other MySQL flavors, or it doesn't exist in other databases, for example, like MySQL doesn't support that. And in this Postgres, I have my data stored in these different schemas. You may recognize some of them from previous streams. We have like some movie data in there. We did some streams about movies. We did some stuff about accidents, which we got from the Swiss Federal Agency of Statistics. Yeah, and we have some other data in there that we haven't really used yet, like weather data. But yeah, I mean, this is stuff for another time, and some street index data, which I'm not really sure what to do with. So we have a Pokemon data set. What does it look like? It looks like this. So I'll just bring this up for you guys. You can take a look. So let's run ourselves through the data so we can have a better idea of what's in here. It's also good for me to remember what's in here. So basically we have the Pokédex number, which is a unique identifier for each of these Pokemon. You'll see that this is not a unique key in this table, because Pokemon can appear more than once due to this code. And the code is basically a reference for different versions of the same Pokemon, whether that's due to regions or like regions within the game, or certain features and things like that. And so we have, for example, this Venusaur, which is the evolution of Bulbasaur, has two versions, one which has overgrow and one which has thick fat. And there's also this ability hidden, which is very interesting because it's something you can unlock. And then there's other kinds of information in here. So let's go back a little bit. So we have the serial, which is a kind of unique identifier derived from a combination of the Pokédex number and the code. You can see here it's the Pokédex times 10 and then plus the code. So it ends up being unique, which is pretty cool. So we can count how many Pokemon we have unique and stuff like that. We have the name of the Pokemon. We have the first type and the second type. Some of them don't have a second type. That is very important to remember when we consider the attacks and things like that and damage that we do. So that's very important. Then we have these classifications, which I'm not so sure what we're going to do with. I think it's just interesting to have classifications, but maybe it will help us figure out a good team or something like that. Squirtle, for example, is a tiny turtle Pokemon. There's a capture rate, which I believe is something when you throw the Pokeball out, something like that. The experience growth, which I mentioned earlier about bringing Pokemon up a level. There's like some experience growth factors, so some of them are just 1 million. Others are 800,000. Some are more than 1 million. Yeah, so it's kind of interesting. Basically, it determines whether it's going to be, I mean, not exponential, but whether the curve is kind of, whether it gets easier over time or not to level them up. Percentage male, which by definition then 100 minus this would be percentage female. That's why it's not included in the database. Base happiness, a legendary flag for a legendary Pokemon. Then there's some stuff about the color and the abilities, which generation they're part of, so we can easily see how many Pokemon are in each generation. We have another legendary flag. Actually, this is probably duplicate. It's probably my fault for merging the two datasets. So we could actually remove this is legendary if we have the legendary flag. Sveni says, hi from Zurich, really looking forward to this. Would be amazing if you turned down the music volume just a bit. No problemo. It's always a bit of a question if it's too loud or not. Thanks for letting me know. Nice to see you're from Zurich as well. So yeah, there is 2 legendary flag columns, so we can definitely get rid of one. So we're gonna alter table. Just double checking this column here. You won't see the tiny pop-up window that came up, but it's basically just an explanation that I've dropped that column. So if I reload the table, that column will be gone. So there's this also a mega evolution, which I'm not so familiar with. Apparently it's something that was introduced a bit later, even though it says generation 1. I think it was a feature introduced later. Then there's these stats about height and weight. These are in meters and kilos, I believe. So 2.4 meters, 150 kilos, that checks out. Venusaur. That's a chunky boy right there. Then we have the information about their health, hit points rather, and then all the stats about their attack and defense and so on. So very, very interesting for figuring out if this is somehow permutable or relatable to other things. Then we have stuff about the eggs. I don't think we'll be going into the eggs today. I would need to read up on it as well about how it works exactly. But more or less the eggs determine how many steps you need to make until an egg hatches, essentially. And then there's different egg groups. Base experience is how much you get for combat. And then there's all these effort ones, which I actually need to look up because I don't remember the effort ones. They are, when the Pokemon is defeated in battle, it will give effort attack values to the Pokemon that participated in the battle against it. Yeah, so this is how much effort it would give Pokemon if it was defeated. And then there's these 18 against features. And basically, these are kind of already engineered from the dataset, which is really cool that I found that already engineered. Otherwise, we would have had to probably create this, which would have made this exercise a lot more complicated, to be very fair. But basically means how much damage. Let's see if I can read this again, because it's a little bit complex. So the explanation is, I'll paste it in chat as well. So the against, so 18 features that denote the amount of damage taken against an attack of a particular type. So if something with a fighting attack hits this Pokemon, it does 0.5 of what the damage would be. And this is against, I believe, Venusaur, right? Yeah, Venusaur. And the reason for that is a fighting attack against grass poison. One of these two, I don't remember which one, is going to do half damage. Jigglestick, welcome. I wrote a battle simulator a while ago. Oh, that's very impressive. I will definitely have to take a look at that. So this is based off a similar data set? I'm going to have to note this down to look at that for later. Gotta simulate them all. That's pretty cool. First generation Pokemon battles. Very impressive. Alright. That's very cool. And you calculate the damage based on the attacks. That's right. So yeah, one thing to note about this against feature is that this is deterministic based on the attack that is received, not the type of Pokemon. And that's kind of important because the Pokemon itself could be grass poison, but it could do a normal attack, for example. Poke API, yeah. So Jigglestick used the Poke API. So I didn't actually want to call the API and do all the requests myself to get the data. I was too lazy. I actually just went to Kaggle and saw what people had already scraped together. But I assume that your data set is very similar to this one, yeah? Because the two that I got from Kaggle were both, I believe, scraped from Poke API as well. Although one might have been from a slightly different site. But yeah, the review that I did with a colleague of mine checked out. I mean, the data seems very plausible. So yeah. So Jigglestick says, yeah, I just had to derive a lot of my own features. You may get some for free. Yeah, so I got these against ones for free, which is nice. I won't be doing any feature engineering, actually, or at least in a data science perspective. I'm not a data scientist by any means. We're doing like really strict descriptive analysis here, where we try and figure out, yeah, what is the data we're working with? And I guess the idea is to give people a glimpse into what is possible with data. Of course, you can go much further, like with machine learning and things like that. And that would be a lot of fun as well, but not something that I can do, definitely not. But thanks for joining, Jigglestick. It's very interesting. I'm definitely going to read that afterwards. Very cool that you showed up. So one of the first things I wanted to do was work out some of these basic stats. And this is kind of something I do if you haven't been in one of the streams before of mine. Basically, I like to create console windows for each particular use case, and then I will save these later, and I can come back to them after the stream, or reopen it in another stream, or reopen it on my own time, and see what I did and see if there's something I can optimize. Because I always believe you can go over your previous work and improve it. And so that's what I do, is I will just close out this window eventually, or we'll keep it open until the end of the stream at least. But just so you're aware that I work in this way. And yeah, as I said in the beginning, this is very much a discovery for me as well this time, because I'm not familiar with this data set at all, even though it is Pokemon. So we're going to see what we get. So one of the first things we want to find out is with a very simple count, is we want to see how many Pokemon are there. I mean, it's basically, this is very simple, but there are 890 unique Pokemon. Now, unique Pokemon means there's 890 Pokemon, but how many variations are there, right? So if we did just a count 1, we would get 1041, right? So this is 1041 Pokemon, including variations. So there are some Pokemon that have 1 or 2 variations. Jigglestick, do you know what generation of Pokemon this dataset is based on? This is all 8 generations, from what I understood from the descriptions. And we can check that as well. that's something I was going to do next. It's like you were reading my mind, which is creepy. So we have generation, and then we can do another count here. I'm going to do dirty queries. So we have here the variations included here, but yeah, it includes all 8. If we were to do the distinct Pokédex number, we would get these 151 in the first generation and so on. This is how many they added per generation. So, okay, we can write this here as well. 8 generations. What else do we want to figure out? I also wanted to figure out a little bit more about the types. But the first thing would be to also see which Pokemon have multiple variations. And that's a pretty easy one. We basically just go like this. We have a Pokédex number, and then we have a count 1, which is how many times they appear. Or we can actually do it like this. If we count how many times they appear in the dataset, we can call this appearances. Is that right? That looks wrong. Appearance. No, that's right. And if we count the appearances, then we can figure out which Pokemons always appear more than once. Oh, oops, no, that's not right. We need to count the number of rows in the data set, sorry. That's not correct. There we go. So we have 6 variations of Pokemon number 479. Now it would be helpful to have the name in here, right? If you haven't been on stream before, I always forget my group by statements. Oh, Jigglestick, thank you for the follow. Much appreciated. So I have a habit of just forgetting to modify my group by statements. So we have Rotom has 6 variations. That's very interesting. Okay, so there's definitely Pokemon here that have way more than just 2 variations. I had assumed it would have been just 1 or 2 variations, but there's quite a few that have 2, and then there's a good number here that have more than 2. We'll have to account for this in doing all our kinds of analysis work later. When we start counting number of Pokemon or something, we'll have to account for that by using the serial. So this was the number that one of the datasets included in order to give a unique ID for each row, and that's very helpful. It's instead of me doing a concatenation, for example, so that's quite nice. So that's interesting. So the 479 Rotom has 6 variations, which is the max. Rotom. It's a shame I can't include the images natively here, because that would be really cool. That would be quite something. So what do we want to look at next? I think one of the next things I wanted to look at was about the types. So if we want to look at just the types themselves, the types are identical, type 1 and type 2. There are 18 types, as we saw from the against features. We saw that there's 18 types. They all have kind of different properties and different meanings, and of course effectiveness. There's some like very interesting intricacies as well. I'm sure like normal against ghost is completely ineffective, I think, or the other way around, like a 0 basically. So there's some stuff like that we hopefully would find out also, looking at the features in the dataset that we already have. But it would just be helpful to figure out how many Pokemon do we have of each type. So we have type 1, and then we could do a count of this distinct Pokédex number. And this is where it gets a little bit complicated, because technically speaking, some of these variations have different types. So maybe we should count the serial instead, because it will give us a more accurate view. You see, I forgot the group by again. I'm just going to leave it here now forever. It's never going to leave. So we have a distribution here of the different types, which it's interesting. There's only 8 flying. Shocking. Okay. That's somewhat surprising for me, but I guess it's certainly possible. Let me just try this also with the Pokédex number just to see. Okay, yeah, so there's a variation in there. Well, it makes sense to maybe work with the serialized ones. I guess it's a decision we're going to have to take at some point about whether we want to consider the variations or not. For me, there are 890 unique Pokemon, and there are just different versions. So maybe we'll just work with the Pokédex number and then only count them once. And if they do have a different variant in a different category, then we're basically double counting them here. Yeah, that's just the way it is. Somewhat inaccurate. So if we wanted to see the percentage distribution here, we could just do this divided by 890. Make this float. Wow, that's weird syntax. So this is the percent share, something like that. Let's order. So we have like, yeah, not even 1% flying, and 12, 13, 14% normal and water, very common. So that's interesting. This might actually have an effect later when we look at the against features, because obviously the distribution of the Pokemon affects how you can assemble a team. I mean, realistically, you might be able to pick those 6 perfectly, but that's definitely an open question. That's something to consider for later. But yeah, we can do this kind of thing too. What would also be interesting to see the combinations of the 2 types. So the way that we can do that, because some Pokemon have a second type, is we can concatenate them. And concatenation basically just means putting values together. And we can just add type 2 here. Love Mesenpai 101 has a question. I'm a former software engineer laid off, wanting to get into business intelligence career. How do you go about this change? Any advice would be greatly appreciated. Sorry to hear about you being laid off. Definitely not so nice. Getting into business intelligence, well, I didn't study anything even remotely related to what I'm doing now. I studied hospitality. So my primary source of advice would be, if it's a passion for you, if it's something you really enjoy, then as long as you get on a path that you'll be learning those things, I think you will be successful in it. That being said, I think the most useful thing to do is to basically pursue continuous learning. That's the thing that I am really into, is I'm basically saying I never know everything, I can't know everything, but I want to learn every day as much as I can. And so I do, for example, Twitch streams, and for everybody that's a little bit different. For some people it might be attending a meetup, listening to a talk, attending webinars, when we can go to in-person events, again going to in-person events, or even just finding someone who's very experienced in a role that you see yourself being in, and asking them to give you some advice as well, and saying, oh, you know, you're doing the thing I want to be doing in 5 years. You know, tell me what do you think the path to success is? I've had several work experience with SQL, but the only thing I've done with that language was creating stored procedures for my work. Is your job all SQL? I would say like 1% of my job is SQL. SQL is a programming language like Python and all others. It's just a means to an end. I think what's really important is being able to ask questions in our type of position. Yeah, really. I mean, 1%, I mean, in terms of time investment, yeah, it's really a very, very small amount of my time. What I really spend time doing is speaking to stakeholders and asking questions and saying, why do you want to find this out? When we tell you an answer, what are you going to do with this piece of information? And I think that's one of the things. So that's one of the things is I would pursue some kind of learning or ask someone who's a sort of in a yeah, idle is maybe a bit overkill, but in an idle role. So Jigglestick's suggestion, the best way to start is look for a company that you want to work for and what requirements you need. And then you have a learning path. Absolutely. I think that's a great suggestion. The other thing you can do is look for people who are in a similar situation to you, who also want to go in that direction, and maybe form some kind of learning group as well where you help each other and say, hey, okay, let's do Code Academy together if we want to learn how to SQL better, for example, how to learn SQL better. But I think coding is just a means to an end. I think you should have an end goal in mind, saying, oh, this is the type of role I want to have. If you want to be programmer, then of course study programming, but you also need to understand how requirements are written, for example, because you'll receive requirements from the business, right? So I think there's a lot of different ways to approach that. But I wish you best of luck for sure, definitely. And I'm convinced that people who have passion, they always achieve their goals, because other people recognize that passion. So, while SQL is a small part of my job, I enjoy it very much, which is why I'm spending Friday evening writing SQL for people on the internet. So now we can concatenate these two types, right? So if Pokemon has two types, then we have type 1, type 2. Then we can concatenate them together and just take the share out and see how many variations of each one. So we'll call this type combo. How many variations exist of each one? Okay, that's disappointing. Ah, yes. So the reason we're having a null here on the top, which is disappointing but expected, is because sometimes the second type is null, meaning it's empty. So we need to do a small workaround. Case when type 2 is null, then type 1. That's our first condition. So case when is like a extended if condition, if you will. Let me just finish the condition and then we can continue with the other whens. When type 1, I guess it's an else then, because we know that type 1 is not null. So we just make else, concatenate them together, and this is the type combo. Oh, nice. Okay, that seemed to have worked. Does that make sense? We have 183 permutations. So we have 183 type permutations. How many would we have expected? We probably would have expected, well, there's 18 types. We would have expected 324 permutations, mathematically speaking. But the game is not made that way, right? We see some permutations that don't exist. For example, I don't know. There might be like, there's no flying fairy or something like that. There probably is, but yeah. Do you like to use Timescale DB? It has a lot of nice features. Essentially, it is a package for Postgres. I've never looked into that. I'll have to note that for also to look at later. Thank you for the helpful links, though. I've never heard of timescale. I do have the GIS plugin activated at the moment for Postgres, the one that allows you to analyze lat/lon geospatial data, which will be for sure at some point a topic for me once I fully understand how to calculate curvature of the Earth and stuff like that. I would like to just understand that a little bit more. But for the moment, it wasn't a topic, yeah. But that looks interesting, timescale DB. It's something I'll have to look into as well. There's just so many things that we could do. Oh, you work in transportation. Then you're most familiar with lat/lon. I'm guessing. Yeah. And not so familiar with Pokemon, perhaps. Although, very, very funny that you made a Pokemon simulator. Yeah. GIS and time series. Yeah, I would like to have a nice time series data set to work with, but there just are not that many out there. I mean, I worked with the Uber data set from the rides, but that was only a small excerpt from like 2014, and only in New York. There are tons. Well, maybe just not some ones that excite me. I don't know. I guess I'm very particular maybe, because I've worked with so many different types of data sets. But you can send me more links, absolutely. You can just whisper me like all the things that you think are interesting, or you can pop them in the suggestion box as well on my profile. Oh, so that's going to be a small change. We need to find a new track. This looks nice. There we go. So I don't have an issue with DMCA yet, but I will eventually, probably. So I'll need to go to some copyright-free music. For the moment, it's not an issue, though, in case anyone wanted to ask. As I'm not a Twitch affiliate, so this is not a paid channel, if you will. Or revenue generating, however you want to say. So let's get back to this Pokédex full. Something we should look at is maybe the classification as well. This is a fairly easy one. We'll just take... Oh, well, actually, one thing I wanted to note. So the most common permutations are single type Pokemon. This definitely seems to be the case. There are some exceptions like normal flying and grass poison in there, but generally speaking, the single type Pokemon dominate. And then there's a huge long tail of all the other Pokemon. So that's very interesting, let's say. That could also be very deterministic for how the attacks will be built up, and what will be very how should I say? A bit lost for words for this thought train of mine. Yeah, basically, if a lot of single type Pokemon are turned out to be better because they're not vulnerable to two types of attacks, basically. Thanks for the links, Jigglestick. I'll take a look at those as well later. Definitely enough to muse over. So let's look at classification. That's an easy one. We basically just type classification, and let's find out. So Shurel says, do we need to deduplicate the combined types? In general, rock-water is the same as water-rock, but as far as I understand, the current statement would then count as two different combos. This is very true. The order, that's very true. So the order of the two types is basically irrelevant. So normal flying normal will count as the same. In this particular count, they haven't counted as the same. That's right, they've been counted separately. So if I look for normal flying, so we can see here, whereas there must be flying normal as well. So there isn't any flying normal, but there's like ghost dark, and there might be dark ghost. Yeah, so those are they're not being double counted, but they're being counted individually. Whereas afterwards, when we try to figure out which combinations are best, we'll need to fuse them together. That is correct. That'll be a little bit more complicated, where we will have to work out basically a concatenation if type 1 is the same as type 2, or rather is if type 1 type 2 flipped the other way is equal, then output as one of the two, for example. Thanks again, Jigglestick. Definitely note those down. There's some in there that would be quite funny. Oh yeah, crime data. I did one with road accidents, but it wasn't so time seriesy. It was already aggregated in a lot of ways. So I would love to have the raw data from that. But thanks for the input, Sherelle. That's a very good point. Most definitely. So I will keep going here with the classification. I just like to have a good understanding of the data set that I'm working with before we go a bit deeper. So there's a lot of different permutations here. There's really like over 500. So there isn't really anything to say about these. I think it's like a classic long tail thing, where there's a very small spike here of like electric Pokemon or whatever. Maybe they weren't so creative in the beginning, but then they just started naming them individually almost. And you can see there's like 2 cream Pokemon and then 2 first bird, but then you get down here like 1 blossom, 1 bulb, 1 centipede. It might be interesting to do some like natural language processing or something. And Jigglestick says, I think later generations of Pokemon changed how cross types' power over others are impacted. That's very possible. But again, the engineered features that I have are deterministic based on the attack received and not the type of the Pokemon itself. Which is good in a way, because it doesn't take into account what type the other Pokemon is, but it's also bad in a way because it doesn't reveal the entire dynamics of the game in a way. If that would be true, which honestly I don't know if it's the case, but it would be interesting to know. Yeah, I'm very happy that this, very off topic, I'm very happy that this stream is very active compared to some of the last ones. I don't know if it's because it's Pokemon and Twitch is very much a gaming focused platform, but it's really nice to see a lot of questions and inputs. So I appreciate that, guys. So the classification for me doesn't really tell me so much. The capture rate, on the other hand, this might be more interesting, purely in terms of just informationally speaking. Okay, that's interesting. So there are some definite peaks, if I want to make this a little bit bigger here. There are some definite peaks in these capture rates. I think that's probably on purpose. I don't know how the capture rate exactly calculates things in-game, but yeah, there are some definite, I would say, patterns. Nothing huge, but there are definitely some patterns. I think the lower the capture rate, the rarer, most probably, or probably have to be the opposite. I wonder what my dataset says. Capture rate. Just looking in the description. The higher the value, the easier it is to catch. Okay, so that makes sense that there's quite a few high valued ones because they want you to get Pokemon early as well so you can level up. That makes sense. Alright, so not everything is worth looking at. I was just a bit curious about the capture rate. The abilities will be very interesting. That's something we can look at. There should be a high correlation to rarity. Yes, capture rate and rarity should be relatively highly correlated. Yeah, absolutely. I don't know if the rarity is not only based on legendary, but based on also some of the stats, probably as well. So funny would be something like looking at the abilities and also the spread of the different attack and defense and things like that. But I have to think about how we want to analyze that as well. I haven't really thought about that yet. Yeah, the against values, that's something I wanted to look at. So I wanted to actually see what the bounds were for these against values. And there isn't really an easy way to do this, other than just copy pasting, which I've just done. There's a nice feature of a lot of text editors, like Sublime as well, which allow you to multi-select lines. And you can avoid having to type this out manually. So I will just put commas here. So we get all the against values. I left the group by in there. We get all the against values. Maybe we can already see some patterns here. 148 rows. Jigglestick, do you plan to create a dashboard or plots during your analysis? Maybe. It depends on what I see as potentially being interesting. I do have a locally powered BI tool running as well. I saw someone, I think it was Love Mesenpai, mention Tableau. So I don't have Tableau running locally for this, but I have Metabase running locally. So we can always put this into Metabase. They're connected, the Postgres database. And we can visualize some stuff that we find. I just don't want to do the raw queries in Metabase. You can write SQL in Metabase too, but I find it more helpful to write them in Datagrip first. But that's very much a personal preference, actually. But yeah, we could, of course, do some plots. The visualization options are relatively limited. Oh, limited. They're the kind of standard options. You don't have the kind of flexibility you would have with something like ggplot in R, for example. That's something for probably later this year. I'd like to do that once I have a bit more of a grasp of how that's working. So what would be interesting for me is knowing the bounds of this entire thing. And just from first glance, it certainly seems like there's zeros possible, which is basically 0 damage. And then there's all the way up to 4 I've seen, possibly 5s. So that's, I just wanted to have an idea of the spread. I don't think there's any double digits in there. That would be kind of crazy. So that's, we can just do here. The easiest way is to cheat. I mean cheat, we're making it easy, right? We just do min, like this. Oh, that didn't work so well. That's because of the last line. The last line doesn't have a comma, so. So these are the min values, which is very interesting. It actually shows something already in terms of gameplay, which is that, for example, Bug and Dark never take 0 damage, but Dragon and Electric do, for example, depending on the attack. That's very interesting. That already reveals a bit of information about the game, which we will come back to most certainly. And then we'll do the max, just to know. This is not something I do all the time, by the way. So the max everywhere is almost 4, but there are 2 exceptions, and I think this is very notable. Dragon. Okay, definitely gonna put this in here. So against, we're gonna put dragon max 2. And I should have used the column names, but I was too lazy. I'm gonna just take out a few until I can count manually. Like I said, this is the lazy way. Normal. Very interesting. So normal caps at 1. So when a normal attack happens, it can never do more than 100% damage. Okay, so we have like a kind of bounds, if you will, for each of these. So we'll say max 4, min 0, or 0.5, 0.25. Dragon max 2, normal 1. I'm just making notes basically for me. Alright, so that's the exploratory part. I have a better idea of what we're looking at now. This total column is something I just wanted to look up because I wanted to make sure I understood it correctly. This is the sum of all the base stats. So if I take these stats, attack, defense, SP attack, SP defense, speed, and total. For each Pokemon, those should be the total. Let's see. So let's do quick maths. 125 plus 230 plus 55. I just wanted to make sure it's not including the HP. Oh, so it is. Alright. So these 5 together are 535. So 106. Oh, sorry about the drop in the music there. So 106. Yeah, this would be correct now. 190, 100, 154, 100, and 130 is 780. Yep. So the total, that's very important for me to note, total includes HP value. Because I would not have necessarily assumed that just from my head. Alright, so we can also do some fun min-max height stuff just to see if that's funny. Probably is, to be honest. Yeah, I'm a little bit surprised at the HP included in the total, but I guess in a way it's part of their total stats. So, and I mean defense is in there, so HP is maybe could be used for ranking, yes. Jiggle stick. So we have, not surprising, 10 centimeters as the minimum height. 14 meters. Oh, I used I wrote height 4 times. It's a bit surprising there. Oh wow. That's probably Snorlax, the one that's 999 kilos. Because they just didn't want to put his real weight. Something we could definitely look at. Name equals Snorlax. Sleeping Pokemon. Oh, he's only 460 kilos. So there's Pokemons that are heavier than Snorlax? Jeez, okay. Well, I already learned something today, that Snorlax is not the heaviest Pokemon. Interesting. Alright. So that was a little bit of exploration, which is fine. And I'm just going to keep that up there. And now comes the first cool part. Pokemon. So what is the first question that we had? The first question I had was how often each ability occurs in the dataset. We have to be careful again with the variations because they have different abilities. But I think we can just do ability and the serial. So if we use the serial, then we account for the variation. So this is like the Pokedex plus variation, right? But we can say, I don't know, we can just keep it as serial. It's not necessarily a bad definition, to be honest. So serial, and then ability 1, ability 2 would be what we're looking for. Basically every single Pokemon with their abilities. Now we have to figure out what's the easiest way to count them. Maybe ability 1, then we'll do let's see. Yeah, that was to be expected, right? Levitate is the single most common ability. That's interesting. It's a defensive attack from what I understand. I mean, if we wanted to go into all the details about the different attacks, I think that would be fairly complicated. But that's, yeah, something to consider. What is the least common ability? Well, there's a couple. Actually, there's a lot. There's quite a few. So there's 63 that are unique abilities. Okay. 63 unique abilities. So there's only one variant of a Pokemon that has that attack, or ability rather. Mimicry. Does this include the abilities you can teach through items, or only abilities learned through evolution? The second, from what I understand. So if you were to, of course, combine two Pokemon, then they could learn other abilities. But this is the ones that they get based on their evolution. Now, this is not including the hidden ability yet. The hidden ability is another point altogether. What I am curious about is if ability 2 is very different. There's still, yeah, okay, there's a small subset of, this is actually misspelled. Flash fire? It could be actually the spelling. Interesting. So there's 518 Pokemon that don't have a second ability. So generally speaking, the majority of Pokemon only have one ability, evolution-wise. Interesting. Makes sense. I mean, especially because you can teach them other abilities. You can also override them, right, from what I remember. Yeah. What about this hidden ability? So a lot of them don't have a hidden ability. 222 over 890. It's about 17%. Is that right? No, that's 25% actually. 25% don't have a hidden ability. Uh, 25% no hidden ability. $63 unique abilities, primary. Telepathy is the most common hidden ability. Okay. The abilities don't affect our analysis. Well, if we look at like the features, the engineered features, they don't affect those analyses because that's based on incoming attacks or incoming attack types. But yeah, I mean that's still very interesting to look at the abilities. I mean, there would possibly be a ability thing if we were to try and correlate them with the stats, like that you could figure out which abilities come with which Pokemon, stuff like that. But so I don't think it's that interesting, to be honest. Yeah. So what I would like to do is put the total, which is the sum of all the stats, in relation to the height and the weight, just to see if they correlate in some way. So we have this function in Postgres called core, which you need 2 values of double precision. And so we'd have to figure out if we want to put the height and weight into like one value itself, or if we want to correlate height and weight together, we could do that. For example, so height is an integer. I don't know. Let's see. Let's see if that works. Probably not, but let's try. Yeah. That's also a nice error. So height and weight are 63% correlated. That's interesting. Okay. Let's do the variation, so the serial, and then look at the correlation between height and weight. Yeah. Group by 1. And it can't do that. And the reason is because the 2 values are only available once per serial. So we would have to group them, for example, by type or something like that. I just don't think it's very, very useful. So the real correlation I would like to look for is the one between the total and the height and weight. And something we could do with the height and weight is maybe, let me think. We could probably log them. Something like this. But if I log them, I could get negative values. So I'd like to get one value for the height and weight, which is representative of the 2, and then use that in correlation with the total to see if there is a link at all. Alternatively, min-max scale them. Yeah, so if we said what's the min height, and then this is like 100% of min or 100% of max. Summing them first, possibility. Let's check. So we just do a few playing around options. So we could try something like, so we have a serial, and then we have height, and then we have weight, then we have total. And then we have here, wow, I have so many group bys just out commented here. Just gonna put a limit in here. So if we have basically, so if we wanted to work out, we know what the maxes are. We know what the maxes are because we did that before, but let's just do that again. So max height, max weight. So we've got the, yeah, okay, but with the weight, there might be an issue that they're certainly not linear. I don't know, let's give it a try. So we got 14.5 and 999.9 for height and weight. So what we do is we take serial and then height, weight, divided by 14.5, weight, divided by 999.9. Let's float these guys to the top of the leaderboard. Yeah. Didn't think my query was finished. Now it knows it is. Okay, so these are the distribution in percent. And then we could then we could actually if we added them together and then did an average. Because if we added them together, we could get more than 100%, technically speaking. Although we could try that. I'm not sure if that's... if they're both over the 50th percentile. Order by to desk. Yeah. So we have some that go over. But I mean, that's also not such a bad thing. Now we see kind of the spread. Let's try this. So I'm just calling this the min-max summed height weight. It's just a very extremely non-confusing alias for this field. And we'll take this out and we will do... Actually, we don't even need to do that. So total equals height plus weight, small equals min total, big max total. Oh, I see. Yeah, could also do it that way. I think I'll do like this and see what happens. Because in a way it also generates a spread, right? If someone has 200% here, then that's the max value, right? The max value is 2, that's all. But this is at least representative for them based on both factors, if we put both in one number. So this would be correlation of this, comma, total. This will be interesting. Okay. Not so correlated. I mean, more than what I thought. Feature scaling. So you've linked something here. Let me just take a look at this. The link looks innocuous. Min-max normalization. Selecting target range depends on the nature of the data. Yeah, then it will give me between 0 and 1. That's true. So yeah, we could do min-max feature scaling. Maybe there's a nice tutorial. There's even one on Code Academy, look at that. Why normalize? Well, that's something we should not cover today. Z-score, etc. Don't want to use Z-score. We can just use the formula. Easy enough. So we have total minus min or the total is going to be equal to that, that's right. So we have the height plus weight. Should probably add them first. Yeah, I agree actually. So if we add the height and weight together, then we can do divided by sorry for the obscure names. I was trying to avoid SQL reserved names. Yeah. Tell me about it. People who name their tables user, for example, particularly annoying. This is an interesting way to do it, though. Just reading the Wikipedia article here. X is an original value. X1 is the normalized value. So we would have, yeah, we would have total minus height and weight divided by the max of the height minus the min height. But I mean, we maybe have to use total here. This is all part of the fun. Must first appear. Oh yeah, of course. It's not gonna like that we're doing this into oh, is it not total minus the height plus weight? But we still have to do them separately because they're aggregate functions, which is fine. So we need min, this. So we'd have group by 1. We need to second one as well. So we'll call this the height weight. This is max total, min total. So we would have then, I'm not going to do a common table expression even though I could, but we don't need it here. Definitely not. So we just have serial. Then we have the HW divided by max total was minus, right? Yeah. Minus the min total. Must have an alias. The alias is T. Alright. Yeah, that was bound to happen. Divide by 0. Oh, of course. But we need to do the max of the height and the weight together, of course. Ugh, that's brain fart moment. Thanks for pointing that out, Jigglestick. We're still gonna have a division by 0 error though, because in some cases max minus the min. Maybe we can't do it by... Yeah. Could be a problem that they are not... shouldn't be an issue. Because here... Oh yeah, we totally forgot to minus that, didn't we? But yeah, it's still an issue with the min-max. Because... Or maybe we need to not include. Yeah, I also think grouping by serial is not good because it's taking out. Yeah, the problem is the height values. Well, we can get around this by just writing a max here. But that's going to cause a lot of issues. Because the height and weight are being considered non-aggregates. This is definitely tricky. Can I use variables? You mean by defining them beforehand? In theory, yes. I've never worked with variables before. But technically, yes. But I wouldn't know how to do that. I'm just trying to understand if... So the divide by 0 isn't an issue if we don't group by serial, because in some cases they will divide by nothing. But the height and weight is being considered a dimension. So each individual Pokemon is being summed. Oh, if we don't need to group by. It's only because we're doing this by row, I'm pretty sure. Not sure if we can do this in one line. Probably not. Can try though. So it would be height plus weight divided by max height. Yeah, it still doesn't like this because we're not grouping them. Basically, it has a value for every row. And that's why... I would probably have to look up how to do that, because I haven't done that in that way before. But... the alternative would be Yeah, I've also never used variables before, so it would be something to learn as well. Just not sure if now during the stream is the right time to learn variables. Maybe it's not so difficult. We can take a look. It's just a declaration. I'm not 100% certain it will solve the issue though. That's the thing. So we have as a function where we can return something. Alias, okay, that's fine. Declaration. All variables used in a block must be declared in the declarations section of the block. Well, we can just call this height weight, and then is height plus weight semicolon. Oh, I think we need to put something in the first. Those are environment variables, those are not the right ones. Oh, but you know, actually vanilla Postgres doesn't support variables, only in PGSQL or PL/PGSQL. But we can use a common table expression that might get around this. So we'll do let's call this, I don't know, HW. Oh, why is this here? Pokemon. So this is now our height weight. And we just do HW. So we have now that in our data set. And then we call this height weight. Yeah, it's still a group by issue. Because we do the calculation. It's definitely solvable. There's always a way. Just wondering if it's that useful to know whether they are correlated. It's something I would have liked to find out, but I'm not 100% certain that it's very useful. But I have an idea of how to try it, and I will try it. And if it doesn't work, then we can move on, I think. So max height weight. So this is then group by oh. I think there's an issue because I think we need to do the min and max are always going to be equal. Always, because values are always being added. But if you do those are going to the minus, because of course they don't scale. I'm gonna move on from this, I think. This one's got me stumped good today. Something I'm gonna look at off stream, because I would like to fully understand that a bit better, and I will need some time for myself to do that. But the one thing I did want to do is figure out a little bit more about these stats. So we have the question of which Pokemon types take most least damage. This is definitely a little bit complicated, because each type, so as we saw before, each type has these against features. So for example, against bug. So we have a grass against bug. We can make this a bit easier to read. We have like a list of all the permutations. So basically, against bug, bug will take 1 normal. However, an electric Pokemon, probably because of type 2, to be honest. I have to concatenate these again, otherwise we're not going to see this properly. Type 2. I'm just going to do the case when, where type 2 is not null. Just for the case for the ones. Yeah, so we have a, I don't like when they're not named, by the way. So basically a water ice Pokemon will take 1 damage, normal damage. So we have like a spread, right, of all the different types and then how much damage they take. So basically anything under 1 is beneficial and everything over 1 is not beneficial. So maybe we could do like this, that for the moment I'm just considering dual type Pokemons. I will come back to the order and stuff like that. But basically I would say case when against bug less than 1, then advantage. Let's say advantageous. Let's do another when condition. When against bug is equal to 1, then we can do it like this, greater than 1, then disadvantage, div, for all you HTML programmers out there. Else normal, and we're going to call this the end as damage type. I want to see if this works. Alright, so we have 165 rows because we have all the different permutations. However, all the different permutations are also in the wrong order. As someone pointed out earlier, Shural, I believe, pointed out, if type 2 is the same as type 1, the other way around. So this could definitely work, that we work out the kind of advantage, disadvantage, and normal situation. And for that we need to also have good music. So let's see what we can find here. Seems alright. Do let me know if it's too quiet or too loud as well. Hard to tell with headphones. I can just monitor the little soundbar here, so in OBS, but it seems to be all right. So we have type 1, type 2, and we need to do a little case when here as well. Let's think about this. So when type 1, type 2, so we can just concatenate them together, is equal to, oh, that's not what I wanted to do. When type 1, type 2 is equal to type 2 concat type 1. Oh, it doesn't like this. I think it's just a syntax thing. Then we're gonna just output it as type 1 with a dash, maybe. Let's do a dash. Type 1 concat type 2. If they're not equal, we have to check whether type 2 is empty. When type 2 is null, then we output type 1. And in all other cases, we would still output type 1, right? Oh, we need to do this check before, because the nulls will run into there. So the nulls would run into that one. We don't want that. So when type 2 is null, then we just take type 1. So if type 2 is not null, then we have this check here, that if backwards they're the same thing, then we'll just output the same thing. And in all other cases, we're just going to output type 1. And we're going to end as final type or something like that. That's a much nicer name. Let's format this the fast way. All right. We have 47 rows. This makes a lot more sense. Now the reason we have... Oh, that's not so good. It's not good at all. So we have some Pokemon. This was what I was a little bit afraid of. We have some Pokemon that are just bug and have a disadvantage against bug. Some Pokemon that are bug that have advantage against bug, and some of the Pokemon that are normal. This doesn't help us. This doesn't help at all. How can it be that there's 3 different damage types? That doesn't make any sense for the game, right? The attack, the bug attack either does normal, disadvantage, or advantage type damage. It can't be all 3. Let's maybe look at one of the attack cases. Oh, whoops, where type 2 is not null. That's a bit of a shitty... I didn't see that in there. Okay, that didn't affect anything, unfortunately.
I'm really excited about all the new tunes and new remixes on my label at the moment.
Okay. Then we're gonna do... Let's try like this. Okay, so there's still the case in there with... What if I don't do an else? Oh, okay. Ah, that was the else causing the issue. Of course. When we had an else in here, this is because it's late at the end of the week. We had an else in here which was causing the following issue. Type 2 was not null, which means it went here. And back and forth, they were not the same. So it went into the else. Which never occurred, or should never occur, rather. We can maybe just do a count here to see. Look at that, I didn't forget the group by, but I did it wrong. Where are the nulls? Okay. I'm definitely going to try and figure out which ones are not falling into this pattern. So let's take out this condition. So we have type. Or it could it be that I don't have the against values for all of the Pokemon? Could it be that simple? So there's one way to check that. We remember how many Pokemon we have. So we do a count 1, where against bug is not null. 1041. Okay. Certainly doesn't seem like we're missing data there. Let's have a look at these types again. Type 1, type 2. Distinct. Bug, 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 bug. Just bug. And let's take against bug. Alright, so... Oh, I see. I see. So... No, but it's correct here. We have bug on its own against bug will only take 1. There's no advantage nor disadvantage. It's normal. So this should be correct in that bug on its own, so bug none, is normal. Yep, it's correct. Order by 1. Yeah, so bug against, so we call this the bug damage type. Or we call it, let's call it damage type bug. That's a bit easier. Or we will probably want to have very short column names. So we'll just call it bug DT. Because we're going to have 18 of these to create this matrix. So bug none. Yeah, this is much better. And the nulls we can take out. I mean, does this cover all the situation? If type 2 is null, then type 1, none. Okay. Let's try like this. Else type 1. Let's make $1 here instead. Sorry if you're not following anymore what I'm doing in chat. I haven't been commenting it so much. Basically here, I'd like to have a matrix of the types with the associated basically disadvantage, normal, advantage, and then I can start to map them to figure out which ones have the most amount of advantage and least amount of disadvantage, kind of, basically. At least on paper. So I want to see. So there are all these permutations that I didn't account for. Why is that? Oh, right. Because sometimes they don't exist in both forms. So, yeah, okay, that makes a lot of sense now. Yeah, basically, the way that it works is the following. Now that I get it, I can explain it. Each of these types can only appear once in each column, right? So we have type 2 is empty, we just use type 1 dash none. If type 2 isn't empty, then it'll go into here, and it'll check if type 1 and 2 can be flipped. So if type 1 type 2 is equal to type 2 type 1, basically, are they identical in opposite order? Then just output it as type 1 type 2. And if they are not identical and flipped, then we just output type 1 type 2, and that means that there is no flipped version. But you know that we'd have to do this check, we have to do at the end, because the final types only exist afterwards, after this check. So what we need to do is do, like, we call this final types. So this is what it's going to look like. We'll have the case when type 2 is null, then type 1 none. If type 1 is equal to type 2, we're not going to do that. Basically, we're going to format it like this. Otherwise, just output them like this. So now we have all these types, the 183 permutations. And now what we do is we do case when. That's the wrong one. Case when type 1 concat type 2 equals to type 2 concat type 1. So basically, when they are identical, then type 1 concat. Let's make a different one so we can see the difference. I think this is right. And okay. Oh, right, because we've already split them, and then we can't split them again here. Oh, man. It's a bit of a tricky one. I did say this would be tricky at the beginning. I hope some of you remember saying that, me saying that. Yeah, because for each Pokemon, the type 1, type 2 flip won't work. It's only in the final list that we have that list that we can go through, that we can permute the whole list. Let me see here. So when type 2 is null, then type 1 dash none, else type 1 concatenate type 2. So this is the final type. What if we include type 1 and type 2 in here? Let me just output this. So bug electric, bug none. Okay, that's fine. This works as expected. So now the question is, can we check in the entire list if there are backwards ones? So basically, if these two are flipped, because they mean the same thing, then we could do 2 columns. Right, we could do, this is type concat, like this. Might have a solution. Let me think about this. These are the same. We only want to count them once. This one's rocking my brain. This one's really jigging my brain. Basically, the order is irrelevant. So if a Pokemon is bug electric or electric bug, so these two are equivalent, which means if we only have these two, then we can say that they are equivalent. So if I do so, this is from there. So each Pokemon gets classified in both ways. I think I'm close. Just need to make that jump from how to figure out that these are identical. I think it's just another case when need to rehash the existing data set. So basically final types, so we put the serial in here. This is FT, and then we do a left join. Pokemon Pokedex full pf.serial equals. So basically if I do case, is there a Postgres function to split a string by delimiter? If yes, you can just invert either and deduplicate. Yeah, I can split by delimiter. I have the original values too. I think it's just a case of saying if you can just invert either type 1 or type cont and deduplicate. So when if I do like type 1 concat dash type 2 equals type concat 1, then type concat 1 when type 2, hold on a second, might be easier. Type 1 equals type concat 2, then put out type concat 1. This would technically work, I think. Else, don't know. Let's end this thing. Distinct 166 bug electric. Is there electric bug? That's the question. Ah, there isn't. So this is the case where type 2 was null. So we do that one first. When type 2 is null, then like this. Still 183. Okay, wait a second. Bug electric. And there's no electric dark. Electric bug. Bug fairy. There's no fairy. Okay, fairy flying. What about flying fairy? No. Fire normal. Normal. Okay, this seems to have worked. Is that possible? Poison fire. Yep. This has worked. It was a long-winded way of doing it, but it worked. Yep. So basically what we did, which is, I mean, it's logical when you think about it, but basically we give each of these a concatenation in both ways, and then check against both of them. And we can do that actually here in one condition. Yes, perfect. So I should only see water bug, and then I should not see bug water. Shit. Why is that? It's really like breaking my brain today. Oh boy. I'm just gonna change up the music because this is not a nice track in my opinion. That's just a preview. That's better. So let me think about this again. We have type 1, type 2 that can be in any order. So Shirel, your suggestion with the Postgres function in terms of delimiter, I mean, I have them individually split anyway. Here I'm just putting them together. So if I could probably do this in one condition. I don't see why I need to do something before. It's nuts. It shouldn't be necessary, really. We can just run through the logic and I'm sure we'll figure it out. So if type 2 is empty, so it's null, then we just write it as type 1 none. If type 1 minus type 2, you see, it's here, it's not checking the whole list, it's just checking its own value in that row. So we need to do else type 1 type 2. That's it. And as concat, for example. I don't know, type concat. Syntax error from. What? All right. So what we have is rock ground is rock ground. Fine. Water, water none. Bug grass, bug grass. The problem is when we have a value that is grass bug, it's actually the same thing as bug grass, which means, oh, I think we need to do like a lookup table for all of the inverse ones. I need to do a Google. 1 second. Okay. There is a reverse function.
After hours.
Oh man. This is pretty crazy. So what I can do is just do a reverse of type 2 and type 1 if it's not empty. So if type 2 is null, do 1. Then I'll do this instead. I'll do else reverse type 2 type 1, and this we're going to call concat I don't know, type rev. Oh gosh. It's just backwards. Oh man, that it's the order which is different. It's not the actual values, it's the order which is different. Type 1, concatenate. Yeah, I mean, basically you just put them together like this. This shouldn't be so hard, honestly, guys. This should not be this difficult, but it is, really. For some reason it is. Either I have a mental block or it's truly way more difficult than I thought. So you have, if type 2 is empty, we do type 1 none. Otherwise we'll do type 1, type 2. This is type 1. We still needed the second one. And if type 2 is null, we do type 1 none, and otherwise we do type 2 type 1. And this is type 2. So in some cases it makes no difference because they're ground, and in some cases they are like this. And now comes the part I need to like map them together, basically. It needs like a mapping table, almost. It'd be crazy, but maybe that's what we have to do. If we don't take the serial like this, just do like that. So these are basically all the types that exist that are equal to one another. Oh yeah, okay. Where? Type 1 not equal to type 2. Now we have all the ones that don't include these. Type 1 does not exist? What? Oh, underscore. So type underscore 1, type underscore 2. So we have 160 that are identical. Bug electric is the same as electric bug. If we were to do a mapping table, how would this work? I would have a mapping table where it says if it's bug electric, it's also electric bug. I think this one needs some fresh air and fresh thinking for it. I think I will call it for today, ladies and gentlemen, because this one needs a bit more thinking, and it is necessary to do this because this will determine the weak, strong types. So I will have a think about this, and we will come back to this on Monday. We will most definitely come back to this on Monday. Monday evening will be the next stream. It is getting a bit late. Maybe it's because of that I can't figure it out, or it's just some blocking thing in my brain that's preventing me. But basically, yeah, I would suggest that we pick this up on Monday. So Shurel writes, there is a split part function. You can split both version by minus, and if version 1 equals version 2 and version 1.2 is version 2.1, you can just take version 1 as type. I will definitely have a look at that. It might be the solution. But for today I'm going to call it. But that's something to look into. Thanks again to everyone who participated in chat today. I hope it was interesting, even though we did not get to any final results yet. But that's, I would say, not unexpected for working with a new data set. And so once again, thank you for joining. And for the links, Jigglestick, I appreciate it. If you have any other suggestions, feel free to put them in the suggestion box. I'm happy to hear topic suggestions or things you'd like to see improved about the stream. And I think if we do have enough viewers currently online, I'd like to go raid someone. Let's see who's online at the moment. Because if there is someone online, then I would love to take a look at who we can raid. So we have don't have so many people online. Yeah, I think we're gonna just call it for today. And I will say thank you very much for joining. And I hope that you got something out of today, and I appreciate the collaboration that we had on today's stream. And hope to see you again next time. Will be Monday around 9 p.m. That's the plan. As usual, the later streams in the week are always a bit more flexible. Friday, Saturday, it kind of depends on which days I'm free. See you next time.